So good morning, everyone. How are you guys doing?
Good.
Good. Yeah? Okay, good. So take out the paper, The Economics of Class Size, if you haven't. Take out So what we're going to do is the lecture is going to be divided into two components. So the first component is going to be a discussion of this class size paper. And the goal of this discussion really is to help us think about how we use the tools that we've learned so far in the course to think about issues that impact the production of education. Another thing that I want to get across as we look at this paper too is to give you some insights into how do you read a paper, how do you understand the audience and the agency. One of the things that's really fascinating about this paper is there's a modeling component that motivates why class size might matter for student performance. Then we talk about what's the ideal experiment that we'd like to run in order to get at that. And then we talk about, well, what is an actual experiment that we do have? And then what are some of the ways in which that experiment deviates from being ideal? How do we get results even in the context of an experiment that's not ideal? How do we interpret these results? What are the coefficients? What are the scientists really from a policy standpoint? And then what are future studies that need to be done? So what we're going to cover today when we look at this paper is going to help you to think about how you can read other research papers too. I know that there are some of you that are interested in graduate school as well, so you get a sense as to what people who are researchers do in terms of setting up a question, framing the question, and then answering that question. So that's the first part. The second part that we're going to look at today is coming up with a Econ evaluation for the quality of schools. We talked a bit about the idea behind that. So you guys have this sheet of paper here from this handout from last class. So these are just 4 slides of a presentation that I put together for this particular paper that has to do with how schools and neighborhoods are being valued. And I have a full presentation that I'll, depending on time, I might go through it to kind of give you like a broader setup of how this is done. This is a really excellent paper that uses data on housing prices to figure out how much households value schools. So oftentimes, families will relocate to a particular neighborhood because the school district that's associated with that neighborhood is very good. And the simple idea is by looking at households at opposite sides of the school attendance boundaries, any differences in the house prices that you see there is largely going to be driven by differences in the quality of schools across that boundary. Because that's the thing that's changing this continuously. So from one side of the street to the other side of the street. So this is a way of measuring how much our household will be paying for a better education. So what I want you to get from the second paper is this is an alternative measure of, this is an alternative way to measure how much households value education. And you always want to be thinking like very creatively about what is the data that you have, what's the question that you want to answer, what's a convincing way to get an answer given the data. Okay. So, all right. So let's first start to ask this question: why might we care about class size? Why is class size important? And whenever you write a paper, you always want to ask yourself the question: why is this important for policymakers? Why is this important for economists to think about? And so, as you write this paper, what are some reasons why class size are important, or why the study of class size is so important?
More student-teacher interaction.
More student-teacher interaction. Okay. And why do we care about more student-teacher interaction?
Because it's more tailored to the student, the teaching process, to their strengths and weaknesses versus just a broad one-size-fits-all.
Okay, and why would we care about teachers tailoring their teaching to the strengths and weaknesses of students?
It affects performance.
Okay, it affects performance. So it's always, so we think about class size as an input into the production of performance, right? And why do we care about performance?
Because we want to maximize performance.
Well, why do we want to maximize performance? Why don't we maximize like how wonderful people feel about themselves? Or why don't we maximize some other thing, right? No, I mean like it's legitimate. It's a very legitimate question, right? So schools now are creating safe spaces, and that's a very important thing as well too, because that's viewed as being very important for students' mental health. So like, why is it that we, and so we can say like we want to maximize safe spaces because that's going to allow students to thrive mentally, right? So why do we want to maximize performance? What is it about performance? What does performance on a test do?
It gets you to a place where you can better help those, the possibility and probability of you feeling better, I guess you could say.
Okay, there's probably an even more fundamental reason why we might care about performance.
reflects back on the school, so if you do well in the school, it'll be more credible.
Okay, so that's one reason. So the school might care about performance because the school actually is going to be paid for performance, right? So there's that accountability measure. What are some other reasons why people care about
Future productivity.
So again,
Future productivity.
talk a bit more about future productivity.
If we create better students now, the society as a whole benefits more later as they go out into the workforce and create goods and services.
Right. This is an example of a long-term outcome. So we think if we educate students better today, they're going to be better able to go into college, and if they go into college, then they're going to get really good jobs, and if they get really good jobs, they're less likely to commit crime, they're less likely to engage in socially reprehensible behavior, and they're more likely to be a credit to society than a burden. They'll pay more taxes, for example, right? They will start companies like Google and Facebook. They will start universities, right? So you always want to start with a motivation, right? Okay, what is the question? We want to figure out what's the effect of class size on student outcomes. And we care about that because class size could be related to performance. We care about performance because performance can be related to labor market outcomes. So you always want to bring it back to economics. So, all right, so paper is the economics. Class size and the goal of this paper is what is the causal, and by causal what we mean is X causes Y. So smaller class sizes cause better, just smaller class sizes cause better performance, not just our smaller class sizes correlated with better performance. So what is the causal effect of class size on student performance? Okay. And then there's why do we care? Why do we care about this as economists? Two, as a society. Right? We answered this question. So as economists, we believe that so it's possible that class size affects performance today, which affects future educational attainment, which in turn is going to affect labor market outcomes. For example, wages and employment. Let's say we just have so having a job and then having a job that pays you well, and etc. And then, as a society, we said that education can also produce better citizens, potentially. So more educated citizenry is more responsible. For example, pay taxes, not criminal, etc. Okay. And so we've set up this question. Okay. Now, me stop there for a moment as you guys write this. So this is what we've talked about so far. So what we're going to talk about next is what is the economic model. So there are two dominant approaches when it comes to economics. So you can have an empirical approach where you take a bunch of data and you say, what do we see in the data? And you can take data on, let's say you had data on student performance and you had data on class sizes. And you looked and you said, well, okay, let's look at average test scores and let's split it by whether there's a large class size, a medium class size, and a small class size. And you see that on average, the test scores in the context where there's a large class size are lower than in all of the other contexts. And you can say, oh, it seems like there's something here in the data. Let's try to investigate this a bit more and see if we can get a causality here, include a bit more variables, see if there's some kind of random variation here. You can go from that direction. Or better yet, you can do what happened in the tendency star experiment and actually create an experiment where you actually randomize people to classes of different sizes. The alternative is to say, well, okay, let's start with the model. Let's think about how is student performance being produced with an economic model where there's costs and benefits. And then from this economic model, what we predict based on the assumptions that we make in this model that there is a relationship between class size and performance. And if so, what is the direction of that relationship? So let's start with this economic model. And it's a very simple economic model. An economic model of the fact class size on performance. So what is the model in the paper, or the model that the paper references? It tries to explain why class size might matter.
SAT scores in the like at the very end it said that smaller class sizes increase SAT scores in white people by like 2%.
So that's the result. So the question is, what's the model? What's the model? So like class size, how does class size affect the production of test scores?
Do you remember the typical empirical model?
Not the empirical model, the theoretical model. It's on the first page. Under why class size might matter. Let's start with the theoretical model. Lazier's model, exactly. Continue.
It just is the probability that a child is behaving in any given moment. B and 1 minus B signifies the probability that they're not behaving.
Right. And so the idea is simple. The idea says if a teacher is teaching a class, the teacher is going to be effective if everyone in the class is listening to what the teacher is saying. And what happens is as the class size becomes bigger, the probability that any one given student is going to be disrupting the class is going to be increasing. Right? And so, given a class of n students, you assume that with probability p, with probability p, that an individual student misbehaves. And disrupts the class. So the idea here is as you get, so what that's going to, say it again.
Isn't the opposite?
Sorry, behaves. Thank you very much. It's 1 minus p that disrupts the class. Thank you so much. Okay. And so what's if the probability of behaving is p for a given student, and all of the students are independent, what's the probability that all of the students behave? Yeah. So this implies that the probability that all students %. And is P, what do we know about a probability? A probability is going to be between what two values? 0 and 1. And so is P to the n greater than, so we know that P is between 0 and 1. So is P to the n going to be greater or less than P to the n? Is P to the n going to be greater than or less than P? That's right. So that implies that P is going to be less than P to the n, right? And if we assume further that the teacher can only make progress if the entire class is behaving, right? Let's assume that the teacher requires the entire class to behave in order to teach. That implies that the probability of teaching is going to be, we call this U. U is going to be equal to P to the n. And then we know that du dn is going to be n minus 1 times P to the n minus 1. So what we can see is that the probability that this teacher is going to be teaching is going to be decreasing in the number of students. We can also see that from here too. Like as we add more students, so say for example, if P was equal to half, then P to the 2 would be a quarter, P to the 3 would be equal to 1 over 8, and so on and so forth. And so as we get a larger class, what's going to happen is the probability that a student is going to be, that all the students are behaving is going to be decreasing in that. And so that's going to be, on the cost side, it's going to be negative about having a larger class. But on the positive side, what's going to be happening is the labor cost for that class is going to be decreasing. Because you have that same one teacher that's teaching all of the class. And so this is the,
Sorry, so P would be less than P to the n?
say that again? P is less than 1. And so the basic idea is that as we go from n equals 1 student to n equals 2 students, for example, the probability that all of the students are going to be behaving is going to go from like a half to a quarter.
So the inequality should be the opposite.
Yeah. So, say that again.
Wouldn't P be greater than P?
Yes, I'm sorry. That was a mistake on my part. Thank you. Thank you very much. That's a very good catch. Yeah. Okay. And so we could even go a little bit further than where this model is taking us so far. We could actually say, well, what's the optimal class size? We can say, well, given that there's a certain benefit to having one teacher, there's the cost benefit to having like just one teacher for the large class, but then on the downside, you're going to get less education being produced. Now, the other component of Lazier's paper too is that what is going to affect P, the probability that a student is disruptive? What are some things that could affect P? So the behavior of other students, but let's abstract from that because for now we're thinking about the the students as being independent.
Is it their age?
Right, so student characteristics, right? So it could be that younger kids are more likely to be disruptive, or older kids are more likely to be disruptive, right? And so then the characteristics of the students become very important. So remember, the last lecture that we were looking at when we were talking about the production of education, we said that there could be some interaction effects. So class size could actually, the effect of class size on student performance could also be very different if the students are of a given age versus a different age. Or it could vary by gender, it could vary by race, or it could vary by any number of these factors as well too. And so that introduces heterogeneity in the way that we estimate this. Okay. Now let's look at our empirical model. So the empirical model that they're going to ask me in this paper is Yij equals A Sij plus B Fij plus epsilon Ij. What's y going to represent? What's y in the model? Yep, y is a student achievement. What is S going to represent? What's S going to represent?
Something like class size.
Yep. So these are, the S is going to represent the school level inputs to student achievement. And what about the F? Yep, F is going to be the family inputs. And the index I is going to be for, this is going to be for the student, and the index J is going to be for the school. Okay. Right. Now, what's an example of something that could be in the epsilons, that could be in the error terms? That we would be worried about. So the thing that we're worried about is if there's something that we don't observe that's correlated with class size. So for example, if class size depends on the ability of the students themselves, so special ed classes, for example, tend to be smaller. Because the idea is that the idea there is that you give students more individualized attention.
Extracurricular activity, like clubs they're interested in, just as people.
And the clubs that they're interested in could be correlated with what in the, could be correlated with which one of these observables.
So I guess student achievement, like if they have a lot of background, or maybe it doesn't like, maybe it's not as directly correlated with those three.
So you can think about a school that has like a really
Could it be correlated with family input? Like people that are gonna do, like maybe some kids do after school activities because their home life is so bad that they don't want to go home. Or they do extracurricular activities because their parents are really intense and are like, if you're gonna go to Harvard, you need to do 50 activities after school.
That's exactly right. So these are so in this epsilon is going to be like, this can be unobserved factors that affect student achievement. And can you guys in the back see here? And the challenge is that the epsilon may be correlated with the S and the F inputs. For example, and I'm going to erase this here. So for example, we can have the situation with extracurriculars where maybe we don't observe the extracurriculars in the school, or we don't observe the extracurriculars that a student is going to be doing. And if a student is doing a lot of extracurricular activities, then we have less time to study. Or the students that do extracurriculars may be the students that are actually the good students. Or the students that do extracurriculars may be the students who are very, who have parents that are pretty intense. And those parents are working more with them. So for example, suppose we do not observe if the student participates in extracurricular activities. this can be a problem if one, the students who pursue extracurricular activities systematically are different those who do not. So this could be, for example, like family background or inputs. And also school inputs. So the family background inputs would be intense parents. School inputs can be better schools, have more extracurriculars. Or it could be the reverse, where like the schools that have more extracurriculars actually have like worse curriculum to begin with because they're spending all of their money on sports. Okay, all right. So here's how we're gonna get around that in the STAR experiment. So let's start to talk a bit about the STAR experiment. So in the STAR experiment, what we're going to do is we're going to randomly assign students to different class sizes to take that into account, or at least to take care of that. Because what we want is that the assignment of the student to a given class size is independent of all of the other unobserved factors. So that's going to be the goal of the randomization. And so that way we can just compare what is the test scores of the students in the smaller classes versus the students in the larger classes. So that's the basic, that's like the golden standard in terms of what we want to get at. Any questions so far? No? You guys look like you're thinking over here. That's good, okay. All right. Did I spell this right? Okay. So you're close to 12,000 students. And in each school, we have students randomly assigned to one of 3 different class sizes. So we have the small class size, which was between 13 to 17 students. Right? We have the regular size, which is between 22 and 25 students. And then we have the large class size. No, sorry. We also have a regular, this is a regular class size with 1 teacher. And then we have the regular size. That's the same one, but with 1 teacher. Minus the teacher's aide. And in the experiment, in some of the conditions, they're going to collapse these two together to be the control. So the way to think about this is the regular size class, which is 22 students to 25 students. And some students were randomly assigned to that class, and these are like the control students. And some students were assigned to a smaller class. These were the treated students. Everybody clear on the experimental design? And this, because it was randomly done, it's not going to be correlated with family background, extracurriculars, or anything like that. The second part of this experiment that's important is this randomization is happening within schools. And so if we have a school that has very few extracurriculars because the school is a low-income school, because we're randomly assigning students to small and large classes within that same school, the overall effect of that school is being controlled. Because we're comparing students who go to the same school, but some students at that same school got to go to a smaller class, and some students got to go to a larger class. Right? So this is a within-school randomization. If we just randomized across schools and we said, well, okay, this school here is going to have all of the small class sizes, and this other school is going to have like the large class sizes, then one potential problem could be that the school that has all the small class sizes is different in other ways overall, right? So that's something that we'd be concerned with. Okay. Now, what I'm going to do is I just want to jump ahead to the results. So if you flip with me to page 186, let's talk about the results so everybody understands what the setup is going to be, right? And I'll just put one more point here. Because of the randomization, correlation of epsilon and f should be equal to 0, and the correlation of epsilon and s should be equal to 0. This is exactly the point. Because typically when we have observational data, we could have a situation where what's happening is the students that are assigned to the smaller class size are being assigned there because they might be stronger students or weaker students. But we get around that with the randomization. Okay. So table 1, who can tell me what is happening in table 1? What are we looking at in table 1? What is table 1 recording? So this is table 1 on page 186.
It's testing like how random the experiment is.
Okay, and how is it doing that?
It's using covariates. That's what it says. It's regressing like maybe it's like regress.